So today we're going to continue our studying of the 18 dimensions. Um, this today we're going to do dimension number 6, pressures. Um, I'm actually pretty excited about this one. So I'm just going to jump right in because it's really like I have to read a good amount to you guys, and then we can kind of have discussions or whatever. Um, okay, so we're talking about pressures today. And um, last time we talked about um the dimension of plane. And so that one kind of goes in conjunction with pressures. So first of all, just this diagram that we have here, we see that he says maximum pressure is up here at the top point of the spiral cone. And also maximum pressure is at the bottom point here of the spiral cone. Because the spirals are winding up matter, accumulating mass. And as it's going through that process, it goes through various planes. And this next diagram, let's see, well, we'll say here, it reads here, generating mass seeks higher pressure zones, and degenerating mass seeks lower pressure zones, right? In the middle here is that zero minimum pressure area. Regeneration is affected by degenerative impact in inertia, thus reversing sex. All right, I'm going to come back to that last little part, but first I'm gonna read you some things about electromagnetic pressures. And for those watching on the replay, when Walter Russell, I'm reading from the Universal One, when Walter Russell talks about electromagnetic pressures, he's using the terms electro and magnetic in a different way than our traditional science. We're talking about gravitation and radiation. Those are synonyms for, electro or electric. That would be gravitation, and then the magnetic would be the radiation. One force is the force coming together. That's the electro or gravitative force coming together. And then the magnetic or radiative force, that's the force, bringing things apart. Okay. So he talks about Euclid, um, and an old Greek, mathematician. And he says one of the axioms used by Euclid in proof of other axioms and postulates reads as follows: figures may be freely moved in space without change in shape or size. And so we can imagine that sounds reasonable. If you have like an item, like I got this little, thing here, and I move it over here or up or down, left, right, in towards you or out, back away, it would seem that it's the same size, right? And that's what Euclid said, hey, figures may be freely moved in space without changing in shape or size. If this is true, then the space between the heavenly bodies is a void, a vacuum. If this is true, then the theory of a non-resistant, pressureless, uniform ether of space is tenable. If this is true, the heavenly bodies must hold themselves in their relative orbits by their mutual attraction and the impetus of their motion. So, and this is kind of Newton's laws, and this is what traditional science thinks, that, like there's the sun, and then you have the planet that's orbiting around. We're thinking, hey, well, it's because the sun and the planet are mutually attracting each other by the force of gravity. The fact that the planet is not just going straight into the sun is because it's hurtling through space, so he's talking about that's the initial impetus. The speed of the planet is is, as Newton would say, it would go in a straight line. But so if it's going in the straight line, but the gravity is pulling it towards the sun, that is why it revolves around, or that's kind of the traditional science. Now, Russell says, if, on the contrary, it can be clearly shown that figures cannot be freely moved in space without changing of size or shape, then a fundamental axiomatic Euclidean principle is not true. It is herein contended that figures cannot move 1 inch in space without change in shape and size, for this entire universe of motion is one of varying but repetitive pressures. So, what Walter is saying that is that when I take this little thing here and I move it just to here, that's more than an inch. He's saying it has changed. It's going to change in its shape and size. Now, it might be a very small change. It might be so small that, our human eyes can't really perceive it. But he is saying that yes, because of pressures, everything changes size and shape at and it depends on, you know, what scale you're talking about. If you're talking about a planet, well, that's a huge scale. The inner planets like Mercury, Venus, Earth, and Mars, they're smaller and like, solid rock planets. If we were to move the Earth all the way out to where Saturn is, oh, it's going to expand, which is shown by the outer four gas giant planets, Saturn and Jupiter, Uranus and Neptune. They're all much larger and gaseous, right? And Russell says that planets are born out of the sun. So they started near the sun and they're expanding away and they're spirals and they're expanding. So as they are moving, they are changing in shape and size. So it's a lot easier for our eyes to see it on that scale because the planets are huge, right? Um, okay. So this one, I mean, like, this is definitely where Russell departs from like traditional science. Like, and as you'll see after I, go through this, like there are going to be some things that we will be able to check Russell's concept versus traditional science. Um, okay, so he says the varying pressures of space are curved. They represent expressions of the energy of motion. All energy of motion expresses itself in waves. All waves are opposed spirals and limited in dimensions. All opposed spiral waves accumulate mass and simultaneously redistribute that accumulation. So let's see. All direction is the direction of opposing pressures. All accumulating mass is aiming towards gyroscopic perfection of motion and toward perfection of cubic crystallization. And we'll go over that later when we do crystallization, another dimension. All diffusing mass is aiming away from gyroscopic stability and away from the simple cubic crystallization towards amorphous complexity of crystallization. Now, when he says gyroscopic um, perfection, that's we're talking about the plane again. It's almost like a top. When a top is spinning around, when it's wobbling, it's at a plane. But if it spins faster and faster, it's going to stand straight up and have gyroscopic perfection. And if you've seen a top that's spinning really fast, it looks like it's literally just standing still, standing straight up. And so that would be the gyroscopic perfection at the position of 4, 4, 4. Okay, let's see. All direction, sorry, the direction of all pressures is spiral. All direction is therefore curved. All curves are spiral. All orbits are spiral. They are all conic sections. Let's see. So an object freely moving in space must move in a curved spiral line, whether that object be a planet, a corpuscle, a quote unquote ray of light, or any other expression of energy. And let's see, further still, any expression of energy in this universe must end where it began. It must be curved. Furthermore, the curve is never a circle, it is a spiral, and its convolutions from its beginning to its ending run the whole gamut of the effects of motion in speeds, temperature, planes, and pressure. All the dimensions are changing as it's going through its life cycle. Furthermore, no curved spiral of motion ending where it began transverses the universe in its journey. The conclusion of Einstein that the universe must be spherical because all direction is curved is based on the assumption that the direction of motion is curved, circular, or elliptical and transverses the whole universe in its passage. But no mass or body or other expression of motion in any state can pass the boundary plane of its own wave of energy. There it is. All right. Okay. So here is diagram of wave pressures. Let me see if I can zoom in a little bit more. I'm going to read a little bit of to describe what this is. This is a diagram from the Universal One, and as you can see, there's a wave. We have, this would be the same thing that you would see on the periodic table, that we've seen Welter's periodic table again and again. Um, so here you would have the inertial plane or zero. Here you would have position +1, and he's labeled that as the lithium line. Position +2, which is the beryllium line, +3 is the boron line, and then the +44 is the carbon line. Okay, and then over here we have the -1 position of fluorine, -2 position of oxygen, -3 position of nitrogen, and then the 4 again, the amplitude. Um, so he says here the axis of the controlling plane of each elemental line has been extended to its opposing focal point and attached to its opposite element. This is indicated by rectangles in order to call attention to their parallel positions. So you can kind of see here you've got +1 right here, and he kind of extends it to this focal point. So you can make, and then on this other side of the wave, you've got the -1 line here and extended. So it makes this rectangle, which he's labeled as violet. And you can see then the position 2, there's another big rectangle, and position 3 is another big rectangle. So he's showing that their positions are parallel. So the universal gyroscope assorts all states of motion by their planes of gyration. Like planes seek each other. So the 4 tones of any octave exactly equal the 4 tones of any other octave in mass energy. To crowd their accumulated forces into smaller volume does not in any way alter their energy constant. So each octave has the same constant of energy. They're just in different dimensions. If they're crowded into a smaller space, it's still the same constant of energy in every octave. But just the dimensions are changing. They're either, larger or smaller. So, he says this is nature's plan of erecting pressure walls during the journey from the universal white light of inertia to its simulation in motion. As we know, the inertial plane is where all the motion starts. Then it journeys towards its amplitude here and its amplitude here. Um, all energy is expressed in waves. All waves are divided into pressure zones. All pressure zones are sustained by pressure walls erected in defined locked potential positions. So we always talk about the formula of the locked potentials. That's that, plus one, plus two, plus three, four, four and minus three, minus two, minus one. And so he's saying that these pressure walls are erected at those potential positions, at the plus one, plus two, plus three. They're walls. And he says here that the mathematical relations are constant. The mathematical relations of any wave of energy never change. All dimensions expand and contract in opposite directions of the same ratio. And once we get to the universal mathematics section, we'll talk more about that, the ratios. But the main thing here to that I want to point out to you is that he's saying that there are that each wave has different pressure zones in the wave. And those pressure zones are marked off by these pressure walls that nature just makes. For some reason, nature, mass will accumulate right at this plus one area at this angle. And so from plus one to plus two, there's this zone, there's like a zone of pressure, of a certain pressure here. Then there'll be another pressure wall there where there'll be a lot of mass, swirling around at this pressure at, this plus three. And I'm sorry, at this plus two, and then another wall at plus three. So in between plus two and three is another pressure zone, which will be higher potential. And of course, same thing, final pressure wall between plus three and four plus plus is like the highest pressure zone. Okay. So now, he says that no mass or body or other expression of motion in any state can pass the boundary plane of its own wave of energy. Every effort of energy sets its own dimensions. Its boundaries are limited by that effort. Energy reproduces itself and thus transfers its expression throughout the universe from wave to wave. But there are dividing walls where motion ceases and begins again, and where all mass disappears to reform again. So we talk about, we've seen before um, here, I'll pull up this picture of cubic wave fields. Oops, sorry, that's the wrong thing I dragged over there. We've seen this before of, cubic wave fields. And so what he's saying is that, this wave in this cubic wave field, this is one wave, from zero up to the corner and from zero down to this corner. So this wave has a definite dimension, and all the mass that's like swirling around in there, it cannot leave this wave here. It can't go over here to this next cube. Okay. Because it's essentially, it starts in the middle. It's going to go up, to the corner, but then it's going to come back. As he said, all motion ends where it began. And so we can imagine these waves are essentially pumping, back and forth, but they're staying in their own wave field. And this one is doing the same thing. It's pumping and staying in its own wave field. But there was a video in the classroom section that I made, and it talks about how that expression is repeated in wave field after wave field, which you guys have probably already seen. Now, energy, he says, energy accumulates as mass and is redistributed in accordance with the increasing and decreasing pressures which it is able to generate. A corpuscle is a mass just as a planet is a mass. You know, an atom is a mass, just as a solar system is a mass. The pressure which an atom of hydrogen can develop varies vastly from that which an atom of radium can develop. They compare with one another as a sewing machine motor compares with a high voltage power plant. All masses, and we got 10 minutes left in this first meeting, all masses, whether they're light units or planets or suns, are compression and expansion pumps, which hold themselves together for a time in greater or less proximity according to the various ratios of their respective compression and expansion powers, in order to simulate the forms being thought out as ideas by by the image making faculty of the one universal mind. It's a fundamental principle of physics that the slightest change in pressure of any substance changes its volume. A change of temperature is one indicator of a change of pressure. Um, every inch of the universe varies in temperature, right? So every inch must therefore vary in pressure. And this is, you know, he's, as we've talked about over and over on this, in this group, is that, you know, all of the dimensions are connected with each other. As one of them changes, the other one changes. All the other 17 of the 18 dimensions change. So he's talking about how when pressure changes, temperature changes. When, you know, when pressure changes, volume changes. Every He says every atom varies in pressure from its exterior to its nucleus. If its temperature is changed, its volume also changes. Also, every kind of atom varies from every other kind in volume, temperature, and all other dimensions. Every kind of atom is in a different plane, and each plane is the pressure wall of one of the varying pressure compartments, which divides the universe of motion into pressure zones. So space, you know, he puts it in quotes, space is made up of atoms of these varying pressures. Traditional science, he says the answer comes back from tradition, but space is void. Is it? He's saying, is it void? It is densely packed with atoms of the high octave, which we cannot see, but which are not beyond the power of our instruments to detect, even if our thinking cannot reveal them to us. And then he talks about a little, I think this is a Rudyard Kipling story about a little village. I haven't read the story, but he says, surely the little village of Kipling's story could be forgiven for voting the world flat, as all men once believed. You know, quite a reasonable human error. It was for, you know, quote, one could see it with one's own eyes, you know, that the earth was flat. You know, there was no illusion about it. It was the most real thing that they knew, a solid thing, flat and motionless, around which the sky turned, right? And for attempting to correct this error, Galileo narrowly escaped with his life, and his statements were almost universally denied. Um, so Walter says, you know, we still measure the orbits of all the planets of this system by our own little Earth's ecliptic instead of by the solar equatorial plane. This may be necessary for local convenience, just as it's convenient for that little village to measure distances to nearby villages and towns from itself. However, he says, if, however, the geographer or historian mapped the whole planet or wrote his history around the little village of his residence as a radial center of comparison, he would, to say the least, be colossally egotistic. Now, the effects of motion of this solar system described herein are based upon the sun, as it is the center, and not based upon the Earth. So the planet's orbits and all precessional motions will also be charted in relation to the solar equatorial plane. All assumed facts of pressure, density, temperature, and the relative power of the attraction of gravitation of this entire solar system are now measured from conditions obtained in this little pea-like village of our solar system without any attempt to translate them into the relative ratios due to relative conditions. So, he's really saying here that, like, us as humans, we are measuring everything in the solar system based upon Earth. Okay. Where when really Earth is like just one small planet of this entire solar system. And he's pointing out, he's like, guys, the sun is the main, is the center of gravity of the entire solar system. We should be measuring things based on the sun, and the relative, like in terms of relative positions of everything, should be based on the sun. But us as humans, we measure it from Earth. So, and he's saying, if a premise is wrong, a conclusion must be wrong. Um, and so he's essentially saying, because we're measuring from the Earth, we're wrong. Like, we're using the Earth as like the main, center of things, that we're wrong. All dimensions are relatively right, but are wrong when measured by units of this planet's standards. Our record of dimensions is in relative ratios. Consider Mercury, a little heavy, hard planet, supposedly less dense than this Earth, but in reality, very much more dense. Crushed in the tremendous pressure of close proximity to the great pressure center of this system, and just recently taken from the furnace, of the sun to cool, it slowly winds its spiral way to where Jupiter now is, but will not be then. Jupiter is not hard. It could not be. Even with its vast bulk, it is not hot as we know heat. Iron would melt there at about 2 degrees. That's like fascinating. And it is in a different pressure zone where releasing pressures expand mass of little volume to mass of big volume. So like he's saying right there, like we think of iron, the melting point of iron here on Earth is like super high. I don't know what it is, but it's, probably thousands, hundreds of degrees, if not thousands. I don't know what it is exactly. But he's saying, out there, the pressure is so much lower there that it would melt at 2 degrees. Um, and Saturn, a vast but pithy planet, would either completely ionize or shrink to insignificance if moved to Mercury's orbit, just as Mercury would explode if suddenly moved to Saturn's orbit. Beyond Neptune, our last known planet, well, he wrote this back in 1926, so we know that there's Pluto was out there, and which is now not a planet, but anyway, he says beyond Neptune, our last known planet, which is but approximately 3/11ths of the distance to the limits of our solar system, there are more planets which are so vast and so tenuous that Jupiter is a pea beside one, and Neptune a solid in comparison. So Walter's literally calling for even larger planets that are further out in our solar system that we haven't discovered, that would be so large and like they'd be like these huge, I don't know, like see-through planets, I guess. I mean, like so expanded and large. So within our solar system are pressures, temperatures, and densities undreamed of by man because miscalculated by him from unit pressures of this planet with which he is familiar. Even man's instruments have deceived him in his calculations, for they but translate states of motion in which units of comparison are but relative, though true in ratio. Man measures the density of the sun by its rigidity as compared with that of our planet. The sun is, therefore, given as 1/4 the density of our planet. It is quite appropriate to state that the density of our planet is 5 times that of water on our planet because the water is part of the planet and subject to the same pressures of our orbital position. Our planet is in a different pressure compartment from that of any other mass. Not so, however, can he compare the pressures or densities of another planet with ours. Relatively, yes, but the low relative pressure and potential which allows rigidity here would vaporize our expanded Earth at the surface of the sun. If removed to Mercury's orbit, our Earth would become white hot. And when it cooled, it would be approximately the size of Mercury. And once again, even when I read some from the Universal One, I don't read the whole thing. I try to pull out kind of interesting things to make the point. But I highly recommend people go back and just read all the books because there's just so many more little details that just, make it that much more rich, for your understanding. Laws governing the measurements in ratios of standard units of distance, pressures, temperatures, and densities, and their translation into standard units familiar to us, will be written down when further consideration of this universe of purely mechanical motion makes it logical to consider its mathematics. And, he's basically saying he's giving us the rules here, but there's still a lot of work that like scientists will need to chart out, you know, all of the relative positions of the different planets and all of the relative densities and temperatures and all of those dimensions of motion. They'll have to be charted out, but they have to take into account that each planet is in a different pressure zone than the other planets. And so once we can get all of that charted out, it's like we'll know so much more about the planets and be able to predict accurately, their accurate densities. And I'm actually working on that. I'm trying to make a calculator based on Russell's concept. Anyway,
That's cool.
that's a project I'm doing. And I knew it had to be done, but I was like, oh my gosh, that's so much work. But thanks to the magic of AI, I am starting to use it. But I have to be very careful as I'm sure Scott, I know that you saw it. I'm not sure, Kirsty, if you saw it, but there was a thread in our group about AI and you know the use of it for Walter stuff. I'm being very careful when I'm using the AI to only source the information from Walter's concept to get the results. And then I will compare those results to traditional science. But anyway, it's a big project and that'll be ongoing. So yeah, he says pressure is that relative state of opposed force necessary to sustain the illusion of relative density of substance in motion. The dimensionless universe of inertia is absolutely stable. The universe of motion is a corpuscular universe of varying but relative density, which simulates the appearance of stability through motion. The greater the positive charge, the greater the pressure of contraction, the less volume. The greater the negative discharge, the greater the pressure of expansion. The greater the pressure of expansion, the less the volume. All solid mass has first been melted by the friction of the active opposition of the two pressures and has then been frozen into the state of relative rigidity by the locking of the opposing pressures into inactive potential positions. So great solidity means less axial activity, Great solidity also means a preponderance of contraction pressure towards high potential. Great axial activity means less solidity. Great axial activity also means preponderance of expansion pressure towards low potential. Let's see. Right. He says the greater the solidity, the greater the instability, but the greater is the illusion of stability. It's difficult for man to comprehend that his dependable solids are but contracting or expanding states of motion, gyroscopically held in apparent suspense for a significant length of time to create the deceptive illusion of permanence. Solidity is therefore but an effect of general active contractive pressure. Like all effects of motion, it is periodic and its tones are in conformity with the formula of the locked potentials. Like all effects of motion, its opposite and equal balancing effect increases its resistance to accumulation as accumulation increases. So, greater positive charge opposed to greater negative discharge means greater potential. There's so much. There's so much in here. But but just to stop and put it in perspective again, let me share my screen one more time. Here it is. So once again, you know, this that we're looking at is in is a two-dimensional representation, just the same way that the periodic table is a two-dimensional representation of the wave. Um, you know, this is the three-dimensional representation of the wave. And it's each one, this is two waves we're looking at here, each one in its own cubic wave field. And so as that spiral winding happens, he's just pointing out that there are these pressure zones from 0 to 1, from 1 to 2, from 2 to 3, and 3 to 4. And all of the matter that's in this pressure zone is going to be at a different pressure and potential than matter that's in the next pressure zone. And these pressure zones are held up by these pressure walls that form at the lock potential positions. And so this is how pressure is related to all of the other um, dimensions of motion. We talked about last week the dimension of plane, and we saw these circles, at +1, circle at +2, +3, +4. Now, in terms of pressure, we know that he's calling pressure walls. And so this is where things are spinning around in this pressure wall. You might see on a huge super large scale, this might be a solar system at 1 and then again at 2 and at 3 and at 4, spinning around to make that pressure wall. But he essentially says that the wave, when you look at this spiral wave, or rather these two spiral cones, one going up here and one going down there, that's a definite volume that is defined by that wave. And all of the matter that's spiraling up in that wave is one total constant of energy. And it's like that in every octave. So like when we look at this picture of this two-dimensional picture, let me zoom out a little bit. When we're looking at this two-dimensional picture, this is one wave here in the middle, and he shows us half of another wave here and a little more than half of another wave over here. So we essentially got one, two, three waves that are interacting here. Um, but no matter where this wave is, it's in an octave somewhere on the periodic table. No matter what octave you're in, you're always going to have these same relative, you know, potential positions of plus one, plus two, plus three, minus one, minus two, minus three, and four, four. Um, and it's always in that wave going to have a certain amount of matter. And that matter can be at different points in the spiral. There's some matter that's kind of over here, but then there's some matter that's between the one and the two and here. That's a higher pressure zone. There's more matter between the two and the three. That's even higher pressure zone. And between the three and the four is an even higher pressure zone, as he's showing these pressure zones that are defined by these pressure walls. And the pressure walls are at the marked locked potential positions. And as we all know, as you go higher and higher towards, one, two, three, four, you get to the apex or the amplitude of the wave. That's the highest potential. And then you come back down, that it goes back to lower and lower potential. So let's see. So that's kind of how we can think about pressure and how it relates to the other dimensions that we've talked about. Now, there are some other interesting things here. Let's see here. So he kind of gives some examples of pressures and how elements will act in these different pressures. So I guess I'll read this. This should be interesting. Greater pressure opposition means higher melting point, less volume, and greater density. A metal which will melt at 2000 degrees at sea level pressure of this planet will still remain frozen solid at 2 trillion degrees in the opposing high pressures of the sun's dense crust. Um, so let me just say that again. So if we're imagining, say, I guess some metal like iron or something that's going to melt, you know, at 2000 degrees, and we are imagining, hey, we're down by the ocean, the pressure is like at sea level on the earth, and you've got this bar of metal, and you need to fire up that, acetylene torch to 2000 degrees and torch that metal, and that's where the metal would melt. And Russell is saying, if you take that same metal and you take it towards the sun, the pressure is so high there that not at 2000 degrees, not at 20,000, it's not going to melt at 20,000 degrees. It's not going to melt at 200,000 degrees. I mean, he literally has the number 200 with 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros behind it. And he's saying because the pressure is so high around the sun that metal would not melt even at 2 billion degrees. But it gets even hotter there, so it's going to melt. So he says a radioactive emission expelled from a low pressure atom may not exceed 10 miles per second. So while that of a high pressure atom of the 10th octave, such as radium, it will approach 186,000 miles per second. That's the speed of light. The increasing contractive electric pressures of the octaves of the elements from 0 through +1, +2, +3 to 4, 4 are accompanied by raising melting points and lowering volumes. The decreasing expansive magnetic pressures from the 4 position back through the 3, -2, -1 down to the 0 are accompanied by lowering melting points and greater volumes. So, he's saying as things are gravitatively coming together and going from lock, lock potential position 1, 2, 3, 4, that means the melting points of things are getting higher and the volume of things are getting smaller. And then when you reverse that cycle on the other side, it's coming back apart, the volume is expanding, and the melting points are lowering. Um, and as usual, axial activity increases as radioactive pressures decrease. Orbital activity increases as gyroactive pressures increase. The entire universe is one of varying potential. Therefore, it is one of varying opposing pressures. And so now he's saying, if this universe is one of varying pressures, then the axiom of Euclid, heretofore quoted, cannot be true. If that state of motion, which is called solid, and he puts in air quotes, solid, is a state in which the tremendous contractive pressures of great accumulation of the energy constant has become molded into compact electric mass of high potential, then those states of motion which are called liquid and gaseous are merely the lower pressures appropriate to the slight accumulation of the energy constant into more tenuous masses. More tenuous masses freeze or melt at lower temperatures, where the resistance to integration is not so intense. An active gas like hydrogen, which leaps explosively into flame from the high opposing pressures of the sun's surface at a speed of thousands of miles per minute, ascends quite leisurely in comparison and without combustion from this planet's lower pressure. Right. So we know hydrogen or helium, they're going to kind of float. They're just going to kind of float up. You've seen a helium balloon kind of just float up. Same thing with you know, if you had a balloon filled with hydrogen, it's just going to kind of slowly float up from our low pressure of the earth. But if that same element on the sun is going to fire out mad and combust. So he says nature builds tonal walls with which she divides her effects of motion. If a pressure wall is developed, it must necessarily follow that somewhere an opposite wall of resistance is set up against which that pressure can develop. This principle holds true in the apparent voids of space, just as it does on this planet in a compression tank, an automobile tire, the depths of the ocean, or thousands of miles within the Earth's crust. Every pressure develops an exactly equal and opposite resisting pressure. Pressures resulting from the accumulation of mass of sufficient density to be perceptible to man would be relatively present in mass, which is beyond man's perception. Man's ether of space is substance in motion, just as molten metal is matter in motion. It is, in fact, infinitely more active, even though that activity cannot be perceived by the senses of man. The evidence of it, however, can be plainly seen and accurately measured. The unseen universe is existent not alone through deduction or as a theory or as a logical conclusion. Every effect of motion is registered in light, and all its pressure walls are visible spectroscopically, each having its own pressure line. And we talked about that when we did color, how there's uh, every element had the if you look at the spectroscope of that element, you'll see these different color lines. All of the 10 octaves are measurable in every dimension, even to the infra and ultra ends. Also, their waves exactly computable and their other dimensions exactly ascertainable. The difference between any one part of space and any other is purely relative in all of its dimensions. The dimensions of the one differ from the dimensions of the others. That is all. Some parts consist of energy accumulated into power by the deceleration of axial and acceleration of orbital speed time, while other parts consist of energy dissipated into the opposite effects of motion. Pressure opposition is but one of the effects of motion. All effects of motion are both gravitative and radiative, but one or the other in preponderance. Okay, and we're almost done here. Just have two little, yeah, let's see, one more section to read here. So there are zones of opposing pressures throughout this universe of motion, which vary in density as the distance increases from the nuclear centers of centripetal vortices. So, like our solar system, the sun is essentially the center of those centripetal vortices, like meeting. Okay. And so as things go out farther away from the sun, the opposing pressures subside. Um, let's see. In every mass, the attraction of the accumulating pressure and the repulsion of the distributing pressure exert their forces in opposite directions. The dimensions of the electric stream increase in inverse universal ratio to the dimensions of the magnetic stream, or in this case, I should say the gravitative stream and the radiative stream. Um, an expanded mass rising in the air has a lifting capacity in respect to the mass from which it is rising. And it also has weight or compression capacity in respect to the potential toward which it is falling. So he says in any mass, the lifting capacity in relation to high potential is equal to the compression capacity in a relation to low potential. The lifting capacity of a gas rising in the air exactly corresponds to the action of a suction pump. It reduces the potential and pressure of the planet by expanding it. So, yes, as the gas is expanding away, say from the Earth, it is literally helping the Earth expand um, and lowering its potential. And then he says, on the contrary, an added weight, say, to the planet, an added weight exactly corresponds to the action of a compression pump in raising the potential and pressure of the planet by contracting it. Consider, for example, the radiation of the sun. The radiation has lifting power in respect to the sun, the effect of which is to degenerate the sun and expand the sun. On the other hand, as that gas goes out into space and then will come to hit the earth, you know, then that gas, it has weight in respect to the planets against which it impacts, the effect of which is to regenerate those planets or, raise their potential up and compact them. And so one of his rules is just the degeneration of any mass is exactly balanced by the regeneration of another mass. And that is essentially all that I'll be reading from that chapter. I know it was a lot, but there's kind of no other way. I like to give you guys directly from the source. And I like how sometimes he talks about, like gases expanding away from something and then will hit something else. It lowers the potential of the thing it's expanding away from, but then it raises the potential of the thing that it hits. So, he talks about how energy will come from the sun. It will then hit Mercury and regenerate Mercury. But then that same energy will leave Mercury and go to Venus and regenerate Venus. And it goes all the way down through every single planet so that the energy is like not wasted at all. And until it finally gets back to, let's see. And if you're still seeing my screen, I think, yeah, you're still seeing my screen. Remember, the sun would be up here. And, its planets would be kind of spiraling around it in this 4-4 potential wall here, or circle, or disc, or plane. And so we can imagine that that energy goes from the sun and it goes out to every planet way out until it goes all the way back to where it came from, which would be over here at the base of this infinitely huge cone that is the cone of energy, the wave that our sun is. Our sun is so huge, like, and our whole solar system would be in this one plane. So the wave that the sun is on is just, unfathomably large. Okay, but he says energy, motion does the same thing on all scales. So, that's what it does, whether it's a small atom or if it's a huge, solar system and sun. So I know that was a lot of reading. I kind of want to hear back from you guys what you think in terms of is this giving you an idea of like pressure, the sixth dimension pressure, and how it kind of goes with the other dimensions? I'm curious to hear. Like, I know, Scott, you've been saying it's, you might already have known this, you know. Kirsty, I know you do your own reading. You may have already read this stuff, but I'm just curious to hear any feedback you might have or any thoughts you might have about today's talking about the sixth dimension of motion.
Yeah,
Um,
it takes a lifetime really of studying because it's so much to grasp and you have to unlearn so much that you've been taught all the wrong things.
yeah, that's right.
It's hard.
You
But
know,
I like this kind of stuff. I love the solar systems and all the things we talk about.
yeah,
It's great stuff.
yeah, I find it fascinating. I don't know. What do you think, Kirsty?
Yeah, it's a lot to wrap your head around. In terms of the universal constant of energy,
Yeah.
Scott asked a good question. Do we know what that is? And in relation to mass, are we saying that mass is the same in every octave and it's so that is the constant energy and mass? We're saying they are pretty much the
Um, I
constant.
actually have, let's
And
see. Okay. Sorry, go ahead.
so octave one, we've got the same amount of mass as we do in octave eight, but obviously the pressure conditions are very different.
I would
But
stipulate that the
is the
density is the biggest difference.
The density
yeah,
and
so
the volume, the actual
yeah,
like
so the
amount of
mass though
space.
it's the same. Are
So,
we saying the mass is the same?
okay.
Obviously the density is very different, but the mass.
So well, that question I can only answer. You have now, that is the perfect segue into universal mathematics, which is,
Uh-huh.
definitely will have to have its own, um, you know, uh, meeting on. But in Russell talks about the the universal constant of energy is X quantity. X quantity is apparently divisible. Its divisibility of quantity and its dimensions are relative and measurable. Um, Now, he said, the dimension X is unimportant, for it represents the illusion of a total of apparent motion, which disappears in the equilibrium of inertia. The, so it's the dimensions of relative ratios are important. For the knowledge of these relations, one will be able to assemble or divide quantities in any desired multiple to produce any desired effect, because all dimensions are relative. All dimensions are either more or less than equilibrium. So, yeah, that kind of x, it's just an x quantity. Um, but it's the same in every octave. It's just in different dimensions. If it's in a higher octave, the volume of will be smaller. The volume of the wave will be smaller, but it'll be more dense though. So it'll still be the same X amount, that it's still constant. It's always constant. Okay, guys. So we only have about a minute left. So um I didn't take any questions at the beginning because I knew this was gonna be a lot to go through. So on our next next Saturday, next time we meet, I can take any questions. But I hope that kind of that X quantity, you can understand that he's just saying that, yeah, there's like this universal constant, but it's the same in every octave, but just with different dimensions, and that's fascinating to me. It'd be interesting to research, like, what is that X quantity? How can we kind of define it? It's going to take looking at all 18 dimensions of the wave to kind of define that X quantity. And so that's where we're heading. We got to understand all the dimensions first and then how they all interact. But yeah, we're getting there. So does that make sense though, Kirsty and Scott, about in terms of the X quantity?
Yeah, so we don't know what the X quantity is. We don't have the formula, but understand the concept, yes, but getting it into practical applications, no.
Right.
See the chat? Look at the chat.
Oh, look at the chat. Yeah, let me look at the chat. I was slacking on the chat. Here we go. Okay. Is it too it is too bad that Walter Russell never wrote the Universal One book two. Oh, I know. I know. He totally says in Universal One, he's like, "Oh, in the next volume, all of these things are going to be charted out and this and that." And I'm like, "Oh, okay." And I mean, one man can only do so much. I mean, like, he only had so much time on the earth. I mean, but he gave so much. Let's see. Then you said, what is the EC and how do we calculate? What do you mean EC?
Energy constant. We just
Oh,
talked
right.
about it.
Right. You're right. Energy constant. Right. And then 2,700 degrees for iron to melt. Oh, thank you. Yeah. We were talking about, yeah. Wow.
It's a little more than that, but around there.
Right. Yeah.
There's a
So,
minute left.
he's right. He's saying like an iron at 2,700 degrees here would melt, but like closer to the sun, you could hit that iron with, 1,000,000 degrees and it's still not going to melt because it's under such pressure. It's so much more compacted together. It's going to take way more energy and higher temperature to break those apart. There's another chapter, like about attraction and repulsion in general. It's a huge chapter. It's not one of the dimensions, but it's very important to Walter's concept. So that as we learn, I want to get through all the dimensions, and then we will kind of go back and kind of go through other things. So okay, now we do only have less than a minute left. So I want to say thank you guys for joining, and it's great to see you guys on the live. And
Same.
hopefully I'll see you next time, and we'll
Yep.
be able to answer more questions because it's a lot. It is a
Oh,
lot.
yeah. Yeah.
And cheers to you guys for hanging in there and learning it. So
Thank you.
yeah. All right, guys. Have a good night. I'll see you next time.
Thank you.
You're
Thanks very
welcome.
much. See ya.